So welcome, folks. This is the last of our talk series for this winter, and this is a talk series as a part of the FairAir project. And my name is Bill Simpson, and I'm from here at University of Alaska Fairbanks. I'm with the Geophysical Institute and also with the chemistry department. I'm one of the organizers of this FairAir project. And our goal in the project is to get a better understanding of indoor and outdoor air quality under Arctic conditions, under cold and dark conditions like we have here in the winter in Fairbanks. You can find out more about our project by going to the website fairair.community.uaf.edu. And this project's really grown out of community concerns. And we had planned to do a field study this winter, but out of concern for COVID, we delayed it for a year. But we wanted to continue the conversation with the community and answer some questions that we've heard around the community a lot. So we decided to focus on indoor air quality and also wildfire smoke, because these come up all the time when we're talking with people around town. And we invited in a few experts on these fields to tell us about the state of the science. There were two talks before this. Delphine Farmer gave an excellent talk about cooking particles and cleaners and health, and that's available on the FairAir website. And then 2 weeks ago, Pete DiCarlo gave a really nice talk about particles indoors and tracing their origins. And this talk will be Emily Fischer, who's going to tell us about wildfire smoke and health. And I just wanted to tell a little bit of logistics here, which is that if people are on Zoom, they can ask questions by putting them into the chat. And if people are on the Facebook stream, they can put questions into the comments, and we'll have people transcribing those questions, and we'll have a time at the end for those questions. So our speaker is Professor Emily Fischer, and she got her BS from UBC on the West Coast, close to us here. And then she seemed to have gone east-west a couple times. So she went east to get an MS from University of New Hampshire, back west to University of Washington to get her PhD, back east to Harvard, and then she kind of averaged it all out and ended up in Fort Collins in Colorado at Colorado State University. So we're really looking forward to your presentation, Emily. Take it away.
Thank you. Can you hear me all right?
Sounds good.
All right, wonderful. Hi, everybody. I wish I was actually in Alaska. It would be fun to come for a visit. I've actually never been to Fairbanks. I've been to Anchorage, but not to Fairbanks. So I will talk today for just under 30 minutes about wildfire smoke and health. I'll start here on this picture because for many of us, wildfires are personal, and it got very personal for me this summer. This is a picture that I took with my family after we cut a backpacking trip short. So I was backpacking with my kids. We were, on day 2 of a backpacking trip, and we sat down at lunch, had a nice lunch, and then I looked up at the ridge line and I saw a plume. And I've spent a lot of time, as I'll soon show you, thinking about wildfire smoke and studying it from all different angles. And I said, oh, we have to run now. And so we were here. This is from InstaWeb, a map of the burn area. That fire ended up being the Cameron Peak wildfire, which became, after burning for 2 months, so it started August 13th, and by mid-October, it was more than 200,000 acres, and it was the largest wildfire in Colorado's recorded history. So this little 5-year-old ran out 6.5 miles in 2.5 hours. And that acreage is big to me, like Bill alluded to. I've gone back and forth, but I went back and forth coast to coast before that little history started. I'm actually from Rhode Island, and so the acreage of that fire is 25% of my home state, bigger than a big wildfire that burned just north of you in 2019, the Hess Creek fire, and probably 20 times larger than the Shovel Creek fire, which as I heard in the intro, when we were chit-chatting was very important to many of you. So this summer, honestly, really rattled me in Colorado. So I study wildfire smoke, I study fires and climate change, but we had just a crazy wildfire season. Here are some pictures of the summer. This is my city park in Fort Collins. You can see the plume above us. This is our ponds. That's me putting my hand down into ash, just collecting on the top of the ponds. Every run that I would do under the smoke plume when the air was okay, you know, there was often ash falling on me, like pine needles and leaves. And then this is my birthday run in mid-October. I turned 40, and there's that smoke plume that we had run from that fire, and it was still going 2 months later. So, so fire is on the mind of many people here in Colorado, and I think across much of the West, because of the strong links to climate change and our health. So today I was thinking this evening we'd talk about how we study smoke and just an overview of what's in it. I'll talk a little bit about how we study the health effects of smoke, what are the health effects, and then just a few slides about what we know about Alaska specifically, which I know very little about Alaska. And actually in prepping for this, I looked and found some recent papers. So wildfire smoke is comprised of particulate matter and a large number of gas phase compounds. So the fine particulate matter, so it's PM 2.5, these are particles that can go deep in your lungs. That composition of that PM is very different than the composition that we typically see from anthropogenic pollutants. So the PM from wildfire smoke is largely organic carbon. There's a little bit of black carbon, and there's a small amount of inorganics, things like sulfate, nitrate, ammonium. But it's largely organic carbon, and that's different than anthropogenic pollutant mixtures. In terms of gases, right, when you burn something, you emit CO2. When you incomplete combustion forms carbon monoxide. And so when smoke comes to town, you'll have these heavy fine particulate matter loadings, and you'll also have these accompanying gas phase pollutants. Other gas phase pollutants that are in the mixture are include hazardous air pollutants, things like benzene, formaldehyde, and honestly, there's thousands of volatile organic compounds, and not all of them have been measured and identified. So there's also many nitrogen containing species. Nitrogen oxides are highly elevated in fresh smoke. So nitrogen oxides are also emitted when we combust really anything, any type of fossil fuel, and also emitted during biomass burning. And then there's a lot of reduced nitrogen compounds as well, and ammonia is one of these examples. So there's actually a really complicated mixture of things in smoke. And what's interesting about it is that smoke, the composition changes with time. So as smoke ages, the chemistry of that smoke is changing. And each of these species behaves differently in this chemical reactor. So some of them photolize, so they break apart under the sun's light. Some of them react quickly, some of them react slowly, some of them are soluble, some of them are not. And so the mixture is ever evolving. So we can understand some aspects of smoke composition from ground level monitoring. And this is just a picture that I snapped in this October. I'm sorry it doesn't have Alaska in it, but I still thought it was a good example. What this map shows is these large smoke plumes in gray. These are from the NOAA hazard mapping system. And so every day analysts use visible satellite imagery and trace smoke plumes that are visible from space, usually from the geostationary satellites. And the dots here are surface monitoring sites, and they're colored here by our HCHOI. So if I know that I'm coming at the end of your air quality discussions here, but for anybody who's new is joining us, you can think about HCHOI as a yardstick for air pollution, right? And down here in the green. The air is green means go. There are very little health risks due to air. And then as you get to these warmer colors, right, you get to unhealthy concentrations. And so here, you know, these surface level monitoring sites, this map shows both the regulatory sites and purple air monitoring network sites, some sites from that network. But what you can learn from this is sort of where the smoke is, right? You can see that in areas with extreme fires in Northern California, you have very poor air quality. In Colorado, we had very poor air quality due to our local fires and also due to these fires moving in from California. But at our sort of local regulatory monitoring sites, the number of different chemical species that's measured is typically quite small. So you know, most locations with people with substantial populations will have, you know, particulate matter and ozone. Maybe there's a NOx and a carbon monoxide monitor. Maybe there might be an SO2 monitor. And then, but there's not really the, let's say, chemical depth that you have to really need to really understand everything about smoke. So we typically have learned more about the composition of wildfire smoke using well-equipped mobile platforms. And so I'll talk to you a little bit about that, and then we can talk a little bit more in the Q&A. But this is a good example of this. So in summer 2018, a large team took the National Science Foundation National Center for Atmospheric Research C-130 research aircraft, and that's what's shown here. And as well as a aircraft that's an NSF facility that's based at the University of Wyoming, just an hour north of me here. And we filled it, and I'll show some pictures of this. We made it into a chemistry lab, and we flew all around the Western US kind of smoke hunting. So we sampled a number of wildfire smoke plumes. And so if you think about the plume that I showed you on 2 slides ago that sort of covers the entire US, it's pretty critical that we understand the composition of smoke because it has a number of impacts. Wildfires now are a main driver of air quality issues in the West. You know, you really can't understand air quality in the West without understanding fires. These fires contain nutrients, so they're important for nutrient cycles, and they're just impacting such wide swaths of the atmosphere that they're important for climate and weather. So the field campaign that I led, where I've, you know, honestly learned more about wildfire smoke composition than one could ever ask, really focused on 3 different topics. And I won't go into much detail here, but I want to give you kind of an overview of how this works. So that focused on fixed nitrogen emissions and evolution, how the aerosol optical properties in the plume. So how does this smoke interact with light? And then what does this smoke mean for clouds in the atmosphere? And so these chemistry topics are important because until you understand the nitrogen, you can't understand how the oxidants change in these smoke plumes. So you can't understand the fundamental chemistry. You can't understand the lifetime of a variety of different species in these plumes. We need to understand how the smoke is interacting with light, just because these plumes are covering they're often blanketing the entire US. And clouds are very interesting and very understudied with respect to smoke. And I think this is kind of an interesting frontier that I won't touch upon today, but except to tell you maybe a little bit about how we sampled it, because it's kind of neat. But clouds process smoke, and smoke also can contribute to the formation of clouds by serving as cloud condensation nuclei, and smoke also contains particles that ice nucleating particles, so particles that form ice clouds. So this is how this field campaign sampled smoke. So here's the C-130, here's a map of the plane. Basically what you do, and I'll show you a picture when you run something like this, is you take out every other seat and you put an instrument in it. So in this map here of the inside of the plane, these are some instruments, and these are where the people operating them sit, and you just fill up the plane. So it looks like this from the back of the plane. There's me, there's my colleague Frank Flocka from NCAR, and this is us in pre-flight. And this is what sort of a flying mobile laboratory looks like on the inside. You can see here some gas cylinders for calibration, and then this, for example, here, this is the instrument that measures nitrogen oxides. This is what it looks like from the front. Here are some grad students from the University of Washington sitting in their seats. That's my group's instrument, and then my students were sitting back here. So what we've done is we based in Boise, Idaho in summer 2018, and we went and we sampled a variety of different smoke plumes. So we sampled the smoke from about 20 different fires. Here's an example I showed in the beginning. When we would get to a fire, we would fly behind it, like I'm showing in the picture here. And then the pilots would turn and follow the smoke plume and then turn directly perpendicular into the smoke plume as soon as it was safe. So outside of the big updraft and outside of any flight restriction due to firefighting efforts. And then what we would do is we would kind of mow the lawn, or for you and for me this week because it's snowing, or shovel the driveway, let's say, across the smoke plume, back and forth, repeatedly sampling it as the smoke is moving downwind to try to understand how the composition of the smoke is changing with time. So we were based in Boise, and when we would go out to an area, you know, the C-130 could fly for about 6 hours. And so you could, you know, fly out to Oregon, for example, in about an hour and a half, spend 4 hours playing in the smoke plume, and then fly back and land. And we sampled the fires during the most active time of the day and the most rapidly growing fires, because in the Western US, most of the burn area is accounted for by sort of very large, the largest wildfires. So this is what it looks like. This is my student Jacob who made these plots for me. Imagine that the fire was here. We had gone with the plane behind it, and then we crisscross back and forth as the smoke plume is moving this way. Oops, sorry, as the wind is pushing it in this direction. And this is what it looks like. So when you fly through a smoke plume like this, it's, you know, when they're so big, so big and so concentrated that when you're outside, often it's crystal clear, and then you fly through and you can see nothing and it smells like a campfire and your eyes might itch a little bit. And then you think, what am I doing with myself? And kind of get out to the other side eventually. These are big plumes. We'd often be in them for, you know, almost a minute, maybe even longer, some of them. You know, more like 3 or 4 minutes, which feels like a long time when you can't see anything in it. And, you know, the sky is kind of this like crazy reddish haze around you. And this is what it chemically looks like when you fly across the smoke plume. And so here we're outside the smoke plume, and then you can see in the orange here is carbon monoxide, goes up quite high. And then, you know, these other tracers, these other compounds are quite elevated in the smoke plume. This is just ammonia as an example. So during weekend, we did multiple, you know, really tight chemistry focused flights. And then we also did some air quality focused flights. So we went down into the Central Valley. That's what I'm showing you here. Here, the dots are showing the AQI at the surface. We went up and down in the Central Valley. This is what it looked like outside of the plane. And then we sampled sort of rivers of smoke, or like complexes of smoke coming from large fire complexes in Oregon and California, and followed them downwind at multiple intervals to try to understand what's different about the smoke when people breathe it near to the fire versus a day or two downwind. I won't spend much time here on this, but we can talk more about it. My team, my research focuses on reactive nitrogen, and my team is unpacking the nitrogen chemistry in smoke. And so when something burns, about half of the nitrogen that's emitted is in the form of N2. Atmospheric chemists don't really care about that because it's not reactive or interesting. And then about half of the nitrogen that's emitted is in a reactive form. And so the arrows here point to these species, and our team quantified all of the species that you can see here that are in the big font, and all of them contain nitrogen. They all have different lifetimes. They all have different processes that are important. Some of them serve as sources of really important oxidants in the atmosphere. Some of them form particulate matter that can deposit quite easily to ecosystems. Some of them have very longer lifetimes and are incredibly stable in the smoke plume. And some of them, like this one down here, are quite toxic. And so that's what this complicated chemistry is, what my team is working on with respect to smoke. My team has also been looking at some other questions that have been driven by societal questions, or honestly, some questions that we get from reporters. And so we've been working using this big data set to understand what the most important hazardous air pollutants are in smoke. And so what we found is the hazardous air pollutants that are most often elevated and likely contribute the most to the gas phase risk. So are things like acrolein, formaldehyde, benzene, and hydrogen cyanide. And what we are finding, though, also is the health risk of the gas phase HAPs in smoke compared to the amount of particulate matter decreases with smoke age. So let's move on to health. So literature, there's a really nice literature base that's forming right now on the impacts of wildfire smoke on health. The literature is thin, honestly, compared to the literature on the health impacts of exposure to what I'm going to call more traditional, regular air pollutants. But what we do know is that populations experience things like exacerbations of asthma and COPD, higher risk of respiratory infections, and there is an increased risk for mortality when smoke comes to town. Identifying smoke impacted air masses is still actually quite challenging on a broad population scale for big areas. And that's one reason why estimating exposure is hard. And that's one of the many reasons why we know less about the health effects of smoke. So if you think about why this is hard, and actually Alaska would be a great example of this too. So imagine that we're at the ground here in my schematic. Here's the city. So let's say that's Fairbanks. Fairbanks has a monitor in one location, or multiple locations, but you might live over here, not near the monitor. And maybe you work over here. When a fire is really active, the way the smoke is emitted is also quite complicated. So you have the smoke rising, and then it's moving downwind, and then sometimes the atmospheric motion draws it down. Sometimes the smoke plume is overhead. And so if you only have a sort of a surface monitor here, here, and here, you really don't know very well what the air quality is. And with smoke, these can sometimes be very narrow bands. Their smoke plumes are very dynamic. And so it can be hard to really understand what people are being exposed to. So our team, what we've been doing and what sort of is the state of the science in sort of figuring out exposure is to take the surface monitors that we have, to Krieg them, or to blend them, and to interpolate between them is a better word. We also use satellite data to say, okay, can we see that there's a smoke plume aloft? And then we'll blend these two observation types together to say, okay, here's an estimate of what the PM is at the surface. And if the satellite says there's a smoke plume aloft as well, then we'll label that as smoke. And so it's hard to get the smoke exposure right. And it's requiring to do it well. It's requiring an understanding of both the surface observations, satellite observations, and often chemical transport models, which the honestly are often have a lot of deficiencies that make it hard. So, but using these kinds of maps and partnering with new teams of epidemiologists, here's some things that we've learned in sort of the last 5 years are also associated with exposure to wildfire smoke. So these kinds of things include respiratory hospital admissions, asthma hospitalizations, asthma emergency department visits, asthma office visits, outpatient visits, increased refills of inhaler medication, below normal lung function. And then we've recently been able to identify, just by doing a better job at exposure and sort of partnering with folks with these health records, higher incidence of preterm birth and decreased birth weight. And so we're really just starting, I think, as a community to sort of get down into more of the lower level. Some of these are sort of lower level, less emergency type things that might happen when smoke comes to town. The other thing that we've been able to know recently by trying to do a better job at exposure, and I think this is something that we'll learn more about, is that air pollution and wildfire smoke, they're associated with increases in domestic crime, actually. And so we partnered with an economist here at CSU, and he used our best estimates of smoke exposure based on multiple different measurements to figure this out. I would say that Alaska, I was actually surprised. I was actually surprised as I started to review the literature. I haven't lived in Alaska, and I've been really focused on working down here in the from Washington, a little bit in British Columbia, but Washington, Oregon, California, and out to Colorado on wildfires in our area. And I would say that for Alaska, studies are just starting to emerge on the impacts of wildfire smoke that include or focus on Alaska. And so I think I'll just mention one of them here, one new one. This paper sort of started to estimate the monthly average wildfire particulate matter for July and August, and map that out. So this paper also highlights what a risk Alaska is for smoke moving forward. So these set of maps show you your sort of average wildfire particulate matter now, how you expect that to change in about 50 to 75 years, and then how that percent change. And so the interior of Alaska, certainly it looks like from the sort of newer studies that are linking climate change all the way to health, we'd expect that smoke exposure will increase based on this study. Here is another one that I've helped contribute to. Micah Hun is a faculty member also in Alaska, so not here in Colorado. And we helped her sort of identify periods of smoke impacted. And she found for sort of these larger population areas, wildfire smoke positively associated with asthma emergency room visits, very similar to what we're finding for other regions, more in other parts of the Western US, and finding that this varies by age, sex, race, and geography. And she also found in her analysis that Alaska natives have a higher risk of cardiovascular outcomes during wildfire events. So I think she would be an excellent speaker for you to have as part of this series if you're having more speakers. So my group at CSU is continuing to work on smoke. So we've sort of worked on the chemistry quite a bit. We're working on figuring out the best ways to blend different observations to assist the health scientists to figure out what the health impacts are. And what I think we need to work on now actually the most is the communication. And so those are the sort of new partnerships that I'm personally starting to build with folks in our journalism and media communications department. So how do we make sure that that everybody gets the right information about smoke? So how much is coming, how much is there now, and then what decisions should they make to protect themselves and their families? And so I think that's really where we need to go, because smoke will be with us for a while. So I'm happy to take questions. I have some links here. This link is a NOVA, will take you to a kind of a fun NOVA podcast that I did right after the fire season. And the person on right after me is a doctor in California that talks a lot about the impacts that they see in their healthcare system with smoke exposure. If you want to know more about, we have a bunch of fun videos. They're like 2 minutes long that take you into the plane, take you into that field campaign. So you can kind of get more of a sense of what sampling smoke is like. And then here I have some resources. I'm starting a new climate change education initiative. And so there's a bunch of nice, easily digestible information about climate change there as well. So hopefully that 32. Okay, time for questions.
Thanks so much, Emily. That was really exciting talk. And yeah, I've seen a number of questions coming in both on Facebook and Zoom. Kelly, do you want to pick out a question or two?
Sure, we've got one from the Zoom chat asking, is this similar to wood smoke from burning wood to heat homes?
So let me answer that in a I don't want to answer that in too simple or complicated of a way. So let me take that a little bit broader. So depending on what you burn, so when you have a wildfire, for example, you're burning, you're burning everything, right? You're burning the leaves, you're burning the soil, you're burning, these sort of extreme wildfires are burning a lot of things. You can also think of a wildfire, you should also think about a wildfire as many different little fires all at the same time. So a mega wildfire will have like a flaming front and then a smoldering sections. And then if it has a big updraft, a lot of that smoke is getting all sucked in. So the major components are the same. The major components of smoke that you burn, of wildfire smoke, campfire smoke, they're largely the same components. The ratios of them will sometimes change, and you'll have slight changes based on the fuel that you're burning. And so there are some nuances there, but there's a lot of different ways that you can burn something. You can, have something that's flaming, you can have something that's smoldering, you have what's called pyrolysis. There's a lot of different processes happening. So every fire is different and every fuel type is different, but this sort of basics that I said in the beginning, fine particulate matter, carbon monoxide, carbon dioxide, thousands of different VOCs, those are in your wood smoke and they're in the wildfire smoke. Which masks, should I be answering the questions as I see them here?
Sure, go for it.
Okay, so which masks best protect against these particulate gases that are linked with health issues? So the gases would not in general be filtered out by your N95. So yes, but what I would like to say about some of the gases, let me answer that a little bit more completely too. So the hazardous air pollutants, you have to think about a little bit differently than the fine particulate matter. So there's a few different things happening that you should think through. So one, the air pollutants that are coming in the smoke are often adding on to the anthropogenic air pollutants that are already there. Two, many of the hazardous air pollutants, we think about that health exposure over long durations, and often this wildfire smoke is a relatively short exposure. Three, when you think about the hazardous air pollutants, and we think about those absolute magnitudes, on an average year, or when averaged out over, let's say, a decade, we've done this for the like CONUS Western US, the health impacts are very small for those hazardous air pollutants. We didn't really know that until this sort of one of our recent studies, but they're relatively small. However, an extreme year, and I think I actually have this as one of my next backup slides here, but in an extreme year, like a 2018, 2020, those kinds of years, then your hazardous air pollutant concentrations will exceed, health risk thresholds. And so for an extreme year like 2018, there are definitely regions where this like hazard index would be sufficient to cause other health effects, but those are rare. But the point is that one of the big points here is that we need to understand this because these extreme years might become more frequent under a warmer world. And so while I could say in the past, the gas-based pollutants probably haven't been an issue, I think moving forward, we might want to think about monitoring formaldehyde, for example, in some of these fire-prone areas. Okay, have you seen the frost fire
Can I
study?
follow up on that, Emily?
Sure.
I was just wondering, and maybe this kind of answers it, but the image there, but what is the length scale? Like how close do you have to be to a fire to have that hazardous air pollution issue?
It's more the duration.
It's duration.
So it's more the duration here. So you can have extremely high concentrations, right? Forest firefighters are exposed to this, right? But you can't really, one other thing I've learned recently too, is you can't extrapolate from what forest firefighters experience to the general public and expect the health effects to be the same at all, right? Because firefighters are typically 20s, 30s, super healthy, super fit. So what it's a duration in addition to a, when you think about the health effects of a pollutant, you have to think about the large population, to figure this out, it's usually a large population with a large exposure over a long time period, right? And so if smoke is in the area for a few days, then in any of these years, you usually don't see crossing of any of these EPA thresholds.
Yeah. So sometimes when we have a fire pretty close, like 2004 or something, it was just months. I mean, long times.
That's like Colorado this summer, right? Like that would be similar to Colorado this summer. We were kind of consistently getting smoke in and out from mid-August till mid-October. Yeah. Oh man. Right. And 2018 was like that for California. That's what's shown here, right? So for California, 2018 had the Mendocino, the Carr fire. Those will make sort of excess cancer risks per a million, of 10 to 25. Yeah. They're small. They're very small numbers. The gas phase pollutants seem to be small. But what we don't know, honestly, is what is the impact of repeated long exposures, right? So we have 2018, then that same region gets hit in 2020. Then what happens we just don't know that. That we haven't figured that out yet. Okay, what's the next question? Have you seen the frost fire study? No.
Yeah, it was a study that was done here a while ago, and it was largely an ecology study. It was a prescribed burn around Fairbanks and about 2000 or so. I think I saw somebody had a hand up. Maybe that was Mike Kraft. If you could type your question into the comments there in the chat, then you can. I
swear I saw a hand too.
Yeah. It keeps disappearing from my.
Oh no, I was going to ask a question, but I'll try to type it in.
Thank you. No, go for it, Mike. If
you kind of touched on it, Emily. I was really curious about the cumulative effect of exposures.
I don't think we know it.
Well,
can I explain why?
Well, I was leaning more to the question. If you just have a second. Yeah. Here in Fairbanks, we go through these winter thermal inversions that really expose us to high levels of emissions relating to PM 2.5 and the precursor gases. And then on top of that, I've lived here 40 years. We end up with a bad fire year. and we never get any relief.
Mhm.
So it's wintertime pollution to summertime fire season. And I was just curious if you guys had any information on that type of exposure.
I don't, but I want to explain one other reason why we struggle to understand the long duration exposures. So if in some of these studies that our team has worked on collaboratively, let me go back here, where we know these things. So the way that works is I tell my epidemiologist friend that I think smoke came to this area of Oregon, and I think it hit these sites at this concentration from, this day to this day, maybe this 2-week period. So then what they do is they use what's called a case crossover design to look at changes in the health outcomes for that period. And so they compare, let's say it was the city of Eugene, Oregon, right? So they say, all right, I'm going to take that population and I'm going to take and look at what happened to that population on the Wednesday before the smoke hit and the Wednesday after the smoke hit. So the same season, right? So that the pollen's the same, the work days are the same, the other exposures are roughly the same. And the only thing that we're assuming changed is the smoke came on the middle Wednesday. And then we'll see, do we see increases in hospital admissions or ED visits as we compare the smoke impacted Wednesday to the non-smoke impacted Wednesday the week before and week after. So if you have these really long durations and it's harder to find your clean Wednesdays, first of all, you end up comparing to outside the seasons. The other thing that you have that makes it really hard to identify the health effects is behavioral changes. And so, for example, in Colorado, when we have our very local fires, it's in the news. In Colorado, there's no trees. So you can see that there's a big smoke plume on the foothills, right? When you have so people are hyper aware of what's happening. It's in the media all the time. And we think people change behavior. Whereas when we get age smoke from California, you're like, is it cloudy? Is that haze? What's happening? People are not as in tune to what's happening, even if we may have a consistently high fine particulate concentration. So that's another thing that's making it really hard to figure out exactly what the health impacts are, because people will also be switching their behavior in different kinds of events. So those are some nuances there of kind of why that's a little bit tricky. Ways to reduce impacts of wildfire smoke during difficult wildfire season. So I think you can break that apart into unpack that in a lot of different ways. So you could stop climate change. That is probably we need to work on climate change. That's a very, very important thing. I am not a forest manager, right? But you could explore the use of controlled burns in the off season, right? You can't usually light fire during the fire season. So if you're already in a difficult fire season, usually can't do prescribed burning, right? Because the risk of starting a fire is too large. You can often back burn things to protect structures, but you can't do real prescribed burning. And then what's tricky is this impact bit, right? Because people have such different, what we call sort of locus of controls. So, someone like me who's a professor, I live in a 1950s house, so I don't have air conditioning, but I have the money to filter my air. So as soon as that fire hit and I ran from it, I immediately came home to my house and I ordered air filters and an air conditioning unit for my old house, because I could just see, I was like, that's in rough terrain. They're never getting ahead of it. It's immediately west of it. It is west of us. That'll hit us. That will burn until there's a fuel break. And this is going to be crazy. And I could see that coming. And I said, I'm going to make this decision to protect my family. But not everybody can make that decision, right? And so we need to think about as a community, people who have lower levels of control over their environment. So how do we build safe airspaces? Is that in the library? Is that in the school? How do we change outdoor indoor activities to protect people. So I think there's a lot of impact reduction that will have nothing to do with the fires, but will have more about, that will be more about more effective communication and sort of advanced training for people of how to respond and read and understand their local air quality and make a decision based on it. That's the best for them, given everything else they have to think about in their lives, their work, their family situation, their income, all these things.
I think there was another question there about the best masks to use if N95s are no longer available. And I also saw a question about the utility of like COVID face coverings in blocking particles.
Yeah, I mean, probably your cloth mask probably doesn't do much. I mean, you know, the more material you force particles to go through, the harder it is. But you know, I think there probably are masks that will be better than nothing, right? But things that have a really good nose fit, really good fit around, have a filter inside them, multiple layers, right? But fine particulate matter is very, very, very small, right? It gets all the way down into your lungs. So any little crack that it can get around, right? A poorly fitting mask, or, you know, filtration that's not as good as the material that's in the N95s, you are going to continue to get exposed to the fine particulate matter.
So I saw there was another one that came in. Is the frequency or intensity of Western US wildfire changing?
Yeah, so the intensity is kind of a hard word to know what that word is. So I avoid it because it's a hard word. So what I can say though is the burn area has been increasing, particularly since the 1980s, and that increase is somewhere on the order for the, I don't know the numbers for Alaska specifically off the top of my head, but for the lower part of the Western US, this is rough. The trend that is sort of reported in these Westerling papers, Anthony Westerling has some really nice papers on this, those changes are something like 20 more additional large fires per decade. So when this paper was published, that's what it is. I think that, you know, you might see some even bigger jumps here in these last few fire years, but it's something like that, like 20 more big, large fires per decade.
Looks like there's a follow-up there asking if the increase is driven by climate change.
Sure, there's definitely a link between climate change and wildfires. And so let me tell you a little bit more about that. So in the Western US, the way we think about this, the way we're thinking about this is what environmental predictors are best explain the year-to-year variability in burn area for different ecosystems. And so not every ecosystem goes up and down with temperature, right? But some do. Particularly the Rockies, where I live, particularly the Rockies, your largest burn area summers are on hot, dry summers. And what we know best about climate change is an increase in temperature, and therefore an increase in what we call vapor pressure deficit, or the thirstiness of the atmosphere. And so the summer, for example, what we saw in Colorado, you know, not every one event can be blamed on climate change, right? But our duration of the fire season was longer, right? We had extreme growth in the fires, and we had a very large drought and very warm temperatures here. So there are many other factors, though, that play into wildfires. So land management is really important, sort of a history of fire suppression, right? All these factors play together. Other issues that are really important is ignition, right? So humans are, you know, tossing more cigarettes, losing control of more campfires, things like that, right? Which will also perturb the fires. And so climate is one piece of it. but it certainly makes us, it certainly primes the world. The conditions are then there for longer and more severe fire seasons.
Yeah, I was just gonna, you mentioned the health studies and the way that you do those. And in Fairbanks, there actually was a wintertime study looking at hospital admissions with similar methodology and relating that to PM in Fairbanks. It doesn't really address the summertime question or the cumulative question of the combination of the two that was asked earlier.
Yeah, and the other thing, just to touch on that, those two different exposures, the composition is really different. Probably, I would imagine, I don't know the composition of Fairbanks air as well as I know the composition of wildfire smoke, but and I know that your Fairbanks air is special in many different ways because you have all these different sources, right? But I'm fairly confident that the composition is not exactly the same in those two mixtures. And certainly not, as I understand Fairbanks, like may not be homogeneous across the whole area.
Yeah,
right?
Yeah, there's definitely spatial variability. In our study, which will be next winter, we're going to finally have really detailed measurements similar to what you had on the plane that can really look. We do have a lot of organic carbon by the normal measurements, you know, half or so of the particulate mass, which is pretty high compared to—
Which is very high for an urban environment, yeah.
Yeah. So, but whether those organic compounds are similar to a wildfire smoke, we don't know at this stage.
You'll know soon.
In a year, we'll know soon.
Yeah.
Which will be awesome.
You'll know very soon, very well, and very soon. Yeah.
Yeah. So it's exciting. Yeah. So I think I'm seeing there were a couple other questions on masks, and I think you covered good fit and good materials.
But I don't study masks, right? So that's the other, that's not my area of expertise.
Yeah. Yeah. But overall, it was really great. We learned a lot, and I think there's, you know, this is a really important thing to us in interior Alaska because there are a lot of fires and
yeah, and I think your populations are highly understudied with respect to smoke exposure.
Yeah, I will say
that's interesting. That's actually interesting. There's actually probably a lot to learn about the Alaska communities because how little literature there is actually in Alaska.
And there have been some recent efforts to get purple air monitors into villages around Alaska. You know, there's both Fairbanks and places on the road systems, and then there's distributed all around the state off the road system villages where there can be really bad fire for long periods of time, and that's all over the interior. So there's been an effort to try and get purple air monitors in there and improve understanding in those areas.
Yeah, I think that's great. I mean, the purple air monitors, there's so much has been invested to in understanding the corrections. I mean, I think that the purple air monitors are awesome, that network. And that's what I was using this summer with my nanny. Honestly, I would say if this threshold crosses red to orange and it says 100 here, kids come inside. So that's the deal. Because it's just, you know, it's the monitor. I can say this monitor is 3 blocks away, somebody's house. Like if it crosses that line, you do this, right?
Yeah.
And it's really such a nice interface. So
it is a nice map, yeah. And there's a fair number around Fairbanks. And you do often see around here people leaving, you know, going to Anchorage. You can go over, it's not a very high mountain pass, but you can go out of the interior and often get relief that way. So you'll see, I think, a lot of behavior change when the fire gets really bad.
Yeah, and you could see it, you know, COVID complicated here in Colorado this year, but I mean, if it hadn't been COVID, I would have taken us to the Northeast, actually. Yeah. Like it's just so smoky here this summer.
Yeah, it is horrible when it's like that. So Mike Music invites you to fly north on your next research program.
I would love to come to Alaska someday.
Yes, we'd love to have you. So great. So thanks so much. This is the last of the talks in the series. And, you know, thanks for all the folks who've been involved. And our intent is to probably start up a couple of talks in the early part of the winter leading into our field study, which will be in January and February. So everybody stay tuned for those talks, more FairAir talks that are going to be pretty closely connected to the field study that we're going to be doing in January and February. So with that, I'd love to thank you. Emily, thanks so much for the talk. And
thanks. I'm going to go put my kids to bed. Good night, everyone. Bye.
Bye-bye.